Hi, my name is Ashley Zamek from Horticulture Innovation. I'm the R&D manager for our pollination portfolio. We invest in a range of projects, but today I thought I'd go through a deep dive on a project I think would really interest you. So first off, who is Horticulture Innovation? Well, Horticulture Innovation is the research and development corporation for 37 different horticultural industries in Australia. You might have heard of other RDCs such as MLA and FISH, but we specifically deal with horticulture, and we do have quite a range of stakeholders. Our biggest stakeholders are probably industries like almonds and avocados, but we also represent quite small industries like nashi pear and custard apples. All these industries pay a levy at farm gate, and this levy is invested in R&D on behalf of them. This R&D tends to be very industry specific and deal with the issues that are facing them now, such as pests and diseases, breeding, and biosecurity. Therefore, these larger multi-industry issues that face horticulture, we tend to deal in more of our Hort Frontiers funding model. Hort Frontiers is a co-investment model and aims to really target those issues that are across industry. And this is where pollination fits. Our pollination fund has three key themes that we invest in. The first is about management of European honeybee. Secondly, we look to optimize crop pollination. And lastly, we looked at alternatives to honeybees, such as other biologicals or mechanical means of pollination. Today, I'd like to talk to you about our project, Novel Technologies and Practices for the Optimization of Pollination within Protected Cropping Environments. This was actually the outcome of a rural R&D for profit grant that Horticulture Innovation, along with 5 key partners, was successful in. This $4.3 million program really aims to understand the issues in protected cropping environments and the things that are happening in regards to pollination. This project started in 2019 and is set to finish in 2023, pending anything else happening in the current landscape. The horticulture industry is currently at a point of change. Climate variability will continue to impact crops each year, limiting the assurance of supply to markets. Customer expectations of year-round availability of fresh produce has increased, and retailers are focusing more and more on producers who can meet these specifications. Historically, there's been a lot of investment in the infrastructure of protected cropping for industries such as berries and tomatoes. But now there is a new focus on crops like cucumbers, eggplants, capsicums, and leafy vegetables. Even fruit trees, tropicals and temperates, and grapes are being trialled with protected cropping in new orchards using hail netting combined with high density systems and dwarfing rootstocks. This is all about de-risking production and maintaining quality to market. When I use the term protected cropping in this presentation, I'm kind of talking about everything from hail netting to polytunnels to glasshouses. There are some real benefits to protected cropping. For example, more growers are using hail netting to stop things like sunburn caused by solar radiation, damage from hailstones, which can bruise and damage the outside of the fruit, even bird damage, which can cause $300 million of damage annually, but is really hard to control because all those birds are natives and can't be killed. So what's the issue with protected cropping? Well, by controlling the environment, we are severely altering that to the detriment of honeybees. We are increasing the temperature and humidity. We are limiting access to floral resources, and we are altering light and airflow. And anecdotally, growers and beekeepers have noticed a difference in the pollination ability and health of honeybees under netting. But we lack that hard data to really show there is a cause and effect, and that's where this project will really shine. Despite the benefits of protected cropping systems, causes of yield deficits have been attributed to lower plant and pollinator performance under enclosed conditions. This project targets methods to optimize honeybee and pollinator performance. At present, honeybees are introduced into many protected cropping systems for pollination, but their performance is often compromised by the conditions they experience, such as greater humidity and temperature, and the impact of low UV light. There is lack of specific knowledge on how to maintain hive health and maintain their performance in protected cropping environments. This project will focus on developing best practice resources that optimize the efficiency of the commercial hives and natural pollinators found in the system that are used in protected cropping environments. As you can see in the overview, we'll be looking at the effect of protected cropping on hive health and how we can improve pollination in those environments and possibly even include mechanical means to supplement honeybee pollination. This will allow beekeepers to better prepare hives and the technology to improve with growers able to innovate how they see pollination and use pollination in existing cropping systems. This will benefit across horticulture, not only those industries currently under protected cropping, but those looking in the future of how they can implement protected cropping to benefit their industry. So now we're going to jump into some preliminary project findings and get an understanding of what is being done under this program. So one aspect we are looking at is trying to understand the effect of netting on numbers, abundance of insects visiting flowers, and that includes the time they actually spent on the flowers. We have some questions including, does the canopy height above the crop affect bee health and orientation? Do bees need access to outside floral resources? Are bees effectively moving pollen under nets? Does netting require perhaps different orchard design and different hive per hectare recommendations? How do nets affect natural biodiversity of pollinating insects, specifically native pollinators, which can contribute up to 30% of pollination in some systems? Nets may even alter the environment so much due to the physical barriers they actually present to wild pollinators that growers may need to consider more hives per hectare to make up for the numbers of lost wild pollinators. So far, results have shown difference in insect abundance and amount of time insects spend on flowers. And you can see that in the graphs below, where there is vast difference in not only insect numbers, but the time they spend on flowers comparing open field systems to closed netting systems. So why is it important that insects spend more time on flowers? Well, time is equated with likelihood of pollen sticking to the body of the insect, and therefore likelihood that the pollen is moved onto the stigma of the next flower, pollinating and creating fruit set. One way we have experimented in encouraging more insects and their activity under nets is to actually open some of the overhead rows in pitched netted blocks. Honeybees and other flower visiting insects have reacted positively to this change. Having a clear space above the trees planted under nets was associated with higher rates of flower visitation by insects, with some growers opening up the sides or above the canopies when able to. So it seems we have a clear solution. However, opening the nets costs growers a lot of money, and it also opens up to risk of environmental conditions that they're meant to be protected from. At the end of the project, we may be faced with no clear winners, i.e., a method that both benefits the beekeeper and the grower, but rather a better understanding of the effects of protected cropping on bee health and the need for more consideration on how they are placed in protected cropping environments. This will be important when planning for the future and understanding how to price hives per hectare and how many to request. This will build better relationships between the beekeeper and the grower for the future. This project not only looks at how bees move under protected cropping, but also the impact of the location of pollenizers. The location of pollenizers can really impact cross-pollination, but are often planted at the edge or in only one part of the orchard to ensure harvesting can be done effectively and efficiently. In open field conditions, we know bees are generally okay in moving pollen over large areas and accessing the right pollinators to ensure effective cross-pollination. However, the compounding effects of protected cropping environments may be impacting the appropriate movement of pollen. So this is something we have done, and as you can see below, we have seen a strong edge effect occurring in these environments. This could mean that growers have to plant more pollenizers, or something that we're experimenting in is creating mobile pollenizer units, so bringing the pollenizers to the bees in those areas. Aside from the work in netting, we've also found some results of the effect of polytunnels. Distance and length honeybees spend under tunnels seems to have an impact. Honeybees visited more flowers in shorter tunnels when compared to longer tunnels. Overall, honeybee flower visitation was found to be higher under netting than compared to polytunnels. The distance from the tops of the trees to the material in general has been found to be an important factor of honeybee visitation. The higher the netting and polytunnel above the crop, the better for honeybees and the more visits. This work is ongoing. So how do we measure and track bee movement? Fluorescent powder is used to mass mark bees as they leave the hives. By tracking the bees and knowing where they came from, we found that bees from colonies located under the netting were more likely to be found foraging in the middle of the block. Bees located on the outside and edge of the block tend to stay in those locations, as you can see here. The top figure shows bees from the hives under the netting, the orange and pink hives, spread down and across the rows of apple trees, whereas yellow marked bees stayed close to the edge of the block, and no blue or green marked bees were detected in our survey. This pattern may reflect an unwillingness for bees to forage under netting when they are located outside the block. The bottom picture shows a second covered block where marked pink bees from hives in the middle of the block were present in much higher numbers in the block center, while the unmarked bees, which were wild bees, were present in higher numbers on the outside. Again, this reflects a pattern that bees located in the middle of the block are happy to be there, while bees outside the block aren't really willing to come further into the middle. Overall, there are indicators that there is potential opposition between hive placement recommendations and those recommended for hive health, i.e. it's better for the hives in regards to their health to be located on the outside of the block, but as we can see in the below, it is better for pollination if we have more hives spread throughout the orchard block, especially in the middle. This is something we'll continue to explore further. I mentioned that hive health is influenced on where they are located in covered blocks, and this was measured by comparing hives located in various positions around a covered block orchard. So the way we measured this was by comparing hives in open controlled environments in open fields, by having hives on the edge of covered blocks, by having hives completely in the middle of covered blocks, and by also having hives in the middle of covered blocks but with a gap overhead. Colony strength was assessed in the morning after hives were deployed, and this is by counting numbers of bees on frames to the closest quarter of a frame. They were again assessed before they were taken out of the orchard. This was done in the morning prior to foraging so we could get a great estimation of numbers of bees and equate that to hive health and strength. Honeybee colonies under the netting lost significant numbers of their adult bees, while colonies in open blocks continued not only to perform better, but actually increase in strength and health. So in contrast, the colonies located under the netting declined in strength, losing an average of 1.4 frames, which amounts to around 11% of all bees. These results tend to show that to prevent bee losses, it may be best to place the bees on the edge of the covered blocks or at least under gaps in the middle. This is to maintain their health, but also maintain their performance. Another really interesting aspect of this work is looking at understanding floral biology to optimize productivity. For example, the attraction of honeybees to blueberry flowers is actually nectar. Unlike other flower species, the honeybee is less likely to be collecting pollen from blueberry flowers, but instead focusing on the nectar. This means that during blueberry flowering periods, we may need to provide other pollen resources to maintain bee health while they're working in blueberry systems. So far, this blueberry work has been produced into a fact sheet, which will go towards our larger best practice guides, which will be done at the end of the project. As I mentioned earlier in the presentation, this program also involves looking at alternative methods to boost pollination through mechanical mechanisms. Different crops require different pollen collection techniques due to their different issues. For example, cherry pollen is considered quite sticky, while seed crops are generally not very attractive to honeybees. Work is being done to review pollen viability and storage to enable mechanical pollination technologies to be used to supplement crop pollination, all in the name of boosting pollination in these protected cropping systems. The next steps for this work is to develop protocols to measure pollen quality and understand the pre and post collection factors that impact pollen viability. This can include things like the cultivars, the growing environment, and also storage conditions. Scalable pollen collection prototypes have been designed and evaluated for onion crops, but work is still ongoing for cherries. The aim is not to eradicate the need for honeybees, but instead supplement pollination for ultimate success. So thank you for coming on this deep dive with me into one of our many projects. I'm always happy to chat, and as you can see, my details are listed on the slide, and I wish you have a great day. Thank you for your time. Bye.